Okay, you guys, I'm doing the 7-5 homework. I started it and then made a mistake, so I'm starting over. Let me catch you up here. For number 3, all I've done so far is graph the trapezoid. And then it says that show that it's a trapezoid. So after I graphed it, I looked at these lines right here, XW and YZ, and I came over here and I found their slopes. And I saw that they're both undefined. They're both vertical lines with no slope. So that meant that they're parallel if they have the same slope, even if the same slope is that it's undefined. And that meant that it is a trapezoid. Okay, and now I've got to decide if it is isosceles. Is it isosceles? So in order to do that, I'm going to do the distance formula between x and y, and then also between w and z. Okay, so between x and y, distance formula will be x2 minus x1. So between x and y. So -3 minus 1 plus, and then y, the y is 9, and the x is, the y for x is 8, so 9 minus 8. That's going to be -4 squared is 16. And that's going to be 1 squared is 1. And so this is square root of 17. And now I've got to do distance formula between w and z. So here we go. W and z. So z, the y, the x is -3. And w, it's 1. And the y here is 3 minus the x here. No, sorry, the y here is 4. So -3 minus 1 is -4 again. Squared is 16. 3 minus 1 is -1. Squared is 1. And this is rad 17. So these are the same. So it is isosceles. Okay. Now for number 5. -2, 0 is m. N is 0, 1, 2, 3, 4. P is 5, 1, 2, 3, 4, 5, 4, 1, 2, 3, 4. And Q is 8, 1, 2, 3, 4, 5, 6, 7, 8, 0. Here we are. Okay, this is a horizontal line. Slope is 0. This is a horizontal line, so the slope is 0. Therefore, these lines are parallel. Therefore, we do have a trapezoid. Now let's see if it's isosceles. I want to see 1, 2, 1, 2, 3, 4. This one is 1, 2, 3, 1, 2, 3, 4. So I know that it's not going to be isosceles just by looking at the fact of this, but you guys don't know right triangles and Pythagorean yet, so unfortunately we have to do the distance formula again. So there's the formula. We'll do it between m and n. M, n. So m, we're taking x's, so 0 minus -2. And then the y's, so 4 minus 0. 0 minus -2 is 0 plus 2. So that's 2. Squared is 4. And that's 4. Squared is 4. Nope, sorry. 4 squared is 16. So this is rad 20. And now I could reduce this radical or get a decimal, but I don't really care how long it is. I only care if it's the same as that. And I don't need to do anything more to be able to compare later. So I'm gonna keep going. PQ, that's these two. So let's do distance formula with P and Q. I'm not gonna have space there. But I do commit to my mistakes, unfortunately, sometimes. So subtracting my x's, 8 minus 5. Plus, subtracting my y's, 0 minus 4. Okay. And then I get 8 minus 5 is 3, squared is 9, 0 minus 4 is negative 4, squared is 16. And this is the square root of 25. So this and this are not the same. So not. Therefore, those 3 dots mean therefore, not isosceles. Okay. Let's hope number 5 is more fun than those. Or number 7, I mean. Find the measure of the angle in the isosceles trapezoid. Whew, thank goodness. Okay. So in a trapezoid, like this guy, I'm going to turn it so it looks normal to me. What ends up happening is that our base angles will be congruent because they said that it's isosceles. So that means that this angle is equal to this angle, but also that this angle is equal to that angle. So now that means that measure of angle J is 118. And then to find L and M, I don't know them. So I'm going to call them X. I know they're the same as each other, so I'll call them both X. And I know that a trapezoid is a quadrilateral, which means that the sum of the interior angles is 360. So what I will do is add them up, subtract from 360. I could also, because these two lines are parallel, these two would have to be supplementary. I could also subtract 180 from 118. Either way is fine. So you could go 180 minus 118, or you can say 118 plus 118 plus x equals 360, and solve. So either way, we will get 2. 7 minus 1 is 6, 62 degrees. So that means that measure of angle L, which is the same as measure of angle M, which is 62 degrees. So this is all the angles. Okay, number 9. Find the length of the mid-segment. Oh, well, the mid-segment is halfway in between the two bases. So the value we need for it is halfway in between these two numbers. How do we do that? We add the two numbers and divide by 2. And it's 14. Okay, number 11. I love number 11. We need to find this number. And the deal is that this is the mid-segment. And whatever this number is, and I don't know it, so I'll call it x. Halfway in between these two numbers is 7. So some people can see that the difference here is 3. So the difference here must be 3. And so this has to be 4. And we could check it. 10 plus 4 is 14, divided by 2 is 7. Cool. If that works for you, great. If not, let's stick with the formula. X plus 10 divided by 2 has to equal 7. So the two bases added together, divided by 2, have to equal the mid-segment, which is 7. Then I multiply both sides by 2. I get 14 equals x plus 10. And then I'll subtract 10 from both sides to get x equals 4. Okay. Number 13, find the length of the mid-segment of the trapezoid with these vertices. So let's see what we're dealing with here. Let me get a little graph going. 2, 0, 8, negative 4, 2, 3, 4, 5, 6, 7, 8, negative 1, 2, 3, 4, 8, negative 4. That was A. This is B. C is 12. Gosh, they're annoying. 8, 9, 10, 11, 12. Oh, you can't see. Okay, so 12, 2, 1, 2. And this is C. And then D is 0, 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's D. What the heck is going on here? This connects to this. This connects to that. This connects to that. And this connects to this. Find the length of the mid-segment. Okay, I've got two options. I can either do midpoint formula between these 2 points to get the middle, then do midpoint formula between these 2 points to get the middle, and that would be my mid-segment, and then do distance formula between those two to get the mid-segment. That's option 1. Option 2 is to find this distance using distance formula, find this distance using distance formula, and then do what we did here. So I don't know why that's the one I want to do. So let's do it. Okay. So I've got the distance formula written down here. And we're going to do the distance between A and B. So I'm going to subtract the x's of A and B, 8 minus 2. And I'm going to subtract the y's of A and B, so negative 4 minus 0. Squared, each one. 8 minus 2 is 6, squared is 36. 4 squared is 16. And negative 4 squared is 16. Okay, I can't believe how bad this comes out to be. I expected nicer numbers. That is rad 52. And rad 52 is approximately 7.2. And then we'll do distance formula between C and D. Too long, I'm sure. Okay. So subtract the x's of C and D. So 12 minus 0. A little secret is that with the distance formula, it doesn't matter if you switch the order of the x's and the y's. So I did 12 minus 0 here, and here I can go 10 minus 2, and it won't matter. But just make sure you're subtracting x's, subtracting y's. Okay, so 12 squared is 144. 10 minus 2 is 8 squared. 8 squared is 64. And then this comes out to 8, 0, 208. I want to verify. And then I need to square root that, and that's approximately, let's see, square root of 208 is 14.4. That's so funny. It's double of that. That's just a coincidence. And then to find the length of this mid-segment in the middle, I got to go halfway in between these two numbers, which means I add them up and I divide by 2. And it's 10.8. Okay. Okay. Number 15, find the measure of angle G. Okay, this is a good one. So in a kite, all right? Two of the angles are going to be the same. It's the two angles between the two sides that are not the same, that are the same as each other. So if this is 100 and that's 40, and I don't know what this is, but I'll call it x, and this is the same, so I'll also call it x, I'm going to go 100 plus 40 plus my 2x, x plus x, and that should equal 360 because kites are quadrilaterals and quadrilaterals add up to 360. So I have 140 plus 2x is 360, subtract the 140, and I get that 2x is 220. Then I'll divide the 2, x is 110 degrees. And measure of angle G is 110 degrees, so that would be a more correct answer to the question. For 17, again, the two angles between the sides that are not the same as each other are the same. So if this is 110, this is 110, and now this is the angle I don't know. And again, it's a quadrilateral, so it adds up to 360, so I'll go 60 plus 110 plus x plus another 110 equals 360. So this is 220 and 60 is 280 plus x equals 360. Subtract the 280 from both sides and I get that x is 80 degrees. And x is the measure of angle G, so measure of angle G equals 80 degrees. Okay. What number was that? 17. So I need 19 here. Let's see what this person did. They have a trapezoid. They have a mid-segment. They subtracted the base and the mid-segment and said that this guy is 6. Well, what we know is that the difference here should be the difference here. So 14 minus 8 is 6. So if we move 6 away from 8, we would be at 2, not 6. That's the problem. Doing this the real way, we would let the side we don't know equal x, and we would do the normal thing. We would say x plus the other base divided by 2 equals the mid-segment. Multiply by 2, 16 equals x plus 14. Subtract the 14, x equals 2. That's their mistake. Okay, in 21, give the most specific name for the quadrilateral. Math people love these questions. So, it's a quadrilateral. All of the angles are 90 degrees. The fact that opposite angles are congruent makes this for sure a parallelogram. And by definition, a parallelogram with 90-degree angles, all 90-degree angles, is a rectangle. And that's as far as we make it with solid math. We know nothing else about this. So the most specific name is a rectangle. Okay, over here, I have a quadrilateral again. And now I know that the opposite sides are congruent. So that, again, gets me parallelogram. I know that all 4 sides are congruent. So that gets me rhombus, by definition of a rhombus. And then now, one of the angles is 90. That makes the angle across from it, because it's a parallelogram, also 90. And then because side-by-side angles in a parallelogram, consecutive angles in a parallelogram add up to 180, if I subtract 90, I see that this angle is 90. And then across from this must be the same, so this angle is 90. And now I have a rhombus where all the angles are 90. By definition, that's a square. See how much it takes to be sure we have a square? Got to make sure it's solid, guys. Got to make sure you have math to back it up, not just it looked like a square or it looked like a rectangle. Alrighty. Now they're giving us something, rhombus, and they are saying decide whether we have enough information to call this a rhombus. This shape right here. Is this a rhombus? Well, I know it's a quadrilateral. I know that the diagonals are perpendicular. Well, that's pretty much all I know. I know nothing about the sides or the other angles, okay? There are two different types of quadrilaterals, at least that we know of, that have perpendicular diagonals, and that is rhombus, but also kite, and also maybe some weird, gosh knows how, one where they purposely make sure it comes out to be a quadrilateral, and a random one that doesn't even have a name could have a perpendicular diagonal situation going. So is there enough information? Sorry, no, they jumped the gun. We would have needed to know maybe that the angles were bisected also. Sorry, I meant like that. Or maybe we needed to also know that all the sides were congruent to each other. I mean, we would have needed to know something more that we didn't. So they didn't have enough to call that a rhombus. Okay. Mathematical connections. We're going to do a mid-segment problem with algebra. No big deal. We're going to add the two bases together. So 3x plus 1 plus 15. We're going to divide it by 2 and set it equal to the mid-segment. That's the formula, okay? Mid-segment of trapezoid equals base 1 plus base 2 divided by 2. Okay, this is 24 nope, this is 25, just kidding. What did I do? I didn't even explain. I multiply both sides by 2 first to get rid of that 2. And 12.5 times 2 is 25. And then up here I have 3x. 1 plus 15 is 16. Then I'll subtract the 16. And I get 9. 3x is 9. X is 3. And that's what they wanted, was the value of x. Okay. Oh my God, look at that cake, and now I want cake. I hope it's vanilla on the inside. Okay, in this diagram, NP is 8. Let's turn this black. It's going to be hard enough to see as it is. 8. LR is 20. What is the diameter of the bottom layer of the cake? This is the bottom layer. It's diameter right here. They've drawn it. This is what we want to know. Guys, I'm going to be honest with you. We got to find this first. Okay? So, between 8 and 20. This is dead between 8 and 20. So I take 20 plus 8 and I divide by 2. 28 divided by 2 is 14. So this is 14. And now I see that the difference from 14 to 20 was a plus 6. So then from 20 to this guy will also be a plus 6. Guys, these are all trapezoids. Trap, trap, trap. Okay, that's why it just keeps going. So 26 inches. Ooh. Determine which pairs of segments or angles must be congruent so that we can prove that ABCD is an isosceles trapezoid. Okay. Okay. In order for this to be an isosceles trapezoid, the base angles must be congruent. So I would need to know that angle C is congruent to angle B. And I would also need to know that angle A is congruent to angle D. That's what I would need. Parallelogram. Okay, so we've got parallelogram here. We've got diagonals drawn, and we know that this diagonal is bisected because they put the tick marks. We do not know whether or not this diagonal is bisected, but if it were, then it would be a parallelogram. So if that and that were congruent, then it would be a parallelogram. And so what we need is for them to tell us that BE is congruent to DE. All right, and that's all.